When people talk about artificial intelligence today, they tend to frame it as a revolutionary force that will completely reinvent business models. This narrative is appealing because it suggests discontinuity, a break from the past. However, from a strategic management perspective, especially if we apply EMAM-level analysis, this assumption is fundamentally flawed. Business models are not primarily technological constructs. They are structured systems of incentives that align behavior across stakeholders: customers, suppliers, employees, and capital providers. Technology, including AI, operates as an enabler, not as the originator of these systems. Historically, every major technological shift has followed a similar pattern. The Internet did not invent new human motivations. It did not change the fundamental drivers of economic behavior, such as profit maximization, risk mitigation, or social signaling. What it did was reduce transaction costs, expand market access, and increase the speed of information flow. AI is operating within the same paradigm. It is not introducing new incentive structures. Instead, it is compressing time, automating decision-making, and reducing the cost of coordination. In other words, AI is transforming how incentives are executed, not why they exist. From an EMAM analytical lens, this distinction is critical because it changes how we approach strategy. If AI were truly creating new business models, then the strategic focus would be on invention. But if AI is merely repackaging existing incentive systems, then the strategic focus shifts toward optimization, recombination, and execution. This leads to the central thesis of this presentation: AI will not reinvent business models. It will repackage old incentive systems into new computational economies. Understanding this thesis allows us to move away from hype-driven thinking and toward operator-level decision-making. Instead of asking what AI can invent, we start asking how AI can restructure existing economic relationships more efficiently. That is the lens we will use throughout this presentation. Let us examine three major technological waves: the Internet, mobile computing, and cloud/SaaS infrastructure. The Internet reduced information asymmetry. It allowed businesses to reach global markets with minimal physical infrastructure. However, it did not change the core incentive structures of commerce. Companies still needed to acquire customers, deliver value, and capture margins. Mobile computing increased accessibility and engagement frequency. It embedded digital interaction into daily life. Yet again, the underlying incentives remained unchanged. Users still responded to convenience, price, and perceived value. Cloud and SaaS transformed cost structures. They shifted capital expenditure into operational expenditure, enabling scalability. But they did not alter the fundamental economic logic of supply and demand. What we observe across all these waves is a consistent pattern. Technology amplifies and scales existing systems rather than replacing them. AI follows the same trajectory. It enhances prediction accuracy, automates repetitive tasks, and optimizes decision-making processes. However, it does not redefine why transactions occur in the first place. From an EMAM perspective, this aligns with the concept of path dependency. Economic systems evolve incrementally, constrained by existing structures and human behavior. Radical discontinuities are rare because they require changes in both technology and human incentives simultaneously. Therefore, when analyzing AI, it is more accurate to view it as a continuation of existing trends rather than a break from them. This historical framing provides a critical baseline. It prevents strategic misallocation of resources driven by the illusion of novelty. Instead, it encourages a disciplined approach focused on leveraging AI to enhance proven models. At the core of any business model lies an incentive architecture. This is the system that determines how value is created, distributed, and captured. An incentive architecture consists of three key components: actors, actions, and rewards. Actors are the participants within the system: customers, employees, partners, and investors. Actions refer to the behaviors that the system encourages: purchasing, producing, sharing, or investing. Rewards are the outcomes that reinforce these behaviors: profits, salaries, commissions, or social recognition. Technology interacts with this architecture but does not define it. AI, for example, can optimize actions by improving decision-making. It can also enhance reward distribution through automation. However, it does not change the fundamental relationship between actors and incentives. This distinction is crucial because it clarifies the role of AI within a business system. AI is not a replacement for strategy. It is a tool for executing strategy more efficiently. From an EMAM analytical standpoint, we can frame AI as a layer within the value chain. It operates at the level of operations and decision support, rather than at the level of strategic intent. This leads to an important implication. Companies that fail to understand their underlying incentive architecture will not benefit from AI adoption. They may improve efficiency, but they will not achieve sustainable competitive advantage. Conversely, Companies that clearly define and optimize their incentive systems can use AI as a force multiplier. They can enhance alignment, reduce friction, and scale more effectively. Therefore, the key question is not, how do we use AI, but rather, what incentive system are we optimizing with AI? To operationalize this discussion, we introduce the concept of computational economies. A computational economy is a system in which economic activities are mediated, optimized, and executed by computational processes. In this context, AI serves as the central coordinating mechanism. The framework consists of three layers: infrastructure, logic, and incentives. The infrastructure layer includes data, computing power, and network connectivity. This is the foundation that enables AI to function. The logic layer consists of algorithms and models that process information and make decisions. This is where AI operates. The incentive layer defines how value is distributed within the system. This includes pricing mechanisms, reward structures, and contractual agreements. AI primarily operates within the logic layer, but its impact extends to the incentive layer by enabling programmable incentives. For example, smart contracts can automate reward distribution based on predefined conditions. This creates a feedback loop where incentives are continuously optimized based on data and performance metrics. From an EMAM perspective, this framework highlights the integration between technology and economics. It shows how AI can transform the execution of business models without altering their fundamental structure. The key takeaway is that computational economies are not new systems. They are optimized versions of existing systems, enhanced by AI. To illustrate this concept, let us examine several real-world examples. First, consider affiliate marketing. Traditionally, affiliates promote products and earn commissions based on sales. This is a simple incentive system designed to drive distribution. With AI, this model is being repackaged. AI agents can automatically generate content, recommend products, and optimize conversion rates. The underlying incentive, commission-based rewards, remains unchanged. Second, consider multi-level marketing. This model relies on network-based growth, where participants earn rewards for recruiting others. In the AI era, we see similar structures emerging in token-based ecosystems. Participants are incentivized to promote platforms and bring in new users. The difference is that AI automates the process and scales it globally. Third, consider consulting. Traditionally, consultants provide expertise and charge fees. With AI, advisory services are being automated. AI systems can generate insights, recommendations, and strategies. However, the underlying incentive, monetizing expertise, remains the same. These examples demonstrate a consistent pattern. AI repackages existing models rather than creating new ones. At this stage, we shift from conceptual framing into economic validation. Any strategic claim about AI must ultimately be tested through unit economics and cost structure transformation. Without this layer, the discussion remains theoretical. We begin with unit economics. Every business model can be reduced to three core variables: customer acquisition cost, CAC, lifetime value, LTV, and contribution margin, CM. AI directly impacts all three, but not symmetrically. First, CAC. Traditionally, acquisition relies on paid media, human sales teams, or brand-building activities. These are expensive and often inefficient due to targeting limitations. AI reduces CAC by enabling precision targeting, automated content generation, and real-time optimization. For example, AI agents can run A/B testing continuously, refine messaging, and allocate budget dynamically. The result is a structural decline in acquisition cost per customer. Second, LTV. AI increases LTV through personalization and retention optimization. Recommendation systems, dynamic pricing, and predictive engagement all extend customer lifespan. However, this is not because AI changes customer motivation. It simply aligns offerings more precisely with existing preferences. Third, contribution margin. AI reduces variable costs, especially labor. Customer service, content production, and even elements of product design can be partially or fully automated. This shifts the cost structure from labor-intensive to computation-intensive. This leads to a fundamental transformation. Labor, right-pointing arrow. Compute, fixed cost, right-pointing arrow. Variable cost, linear scaling, right-pointing arrow. Non-linear scaling. In traditional models, scaling requires proportional increases in labor and capital. In AI-enabled systems, scaling becomes non-linear. Once the model is trained and deployed, incremental output can be generated at near zero marginal cost. However, this efficiency gain introduces new risk layers. First, model drift. AI systems degrade over time, if not continuously updated. This creates hidden maintenance costs. Second, hallucination risk. Incorrect outputs can damage brand trust or create legal exposure. This is particularly critical in regulated industries. Third, compliance cost. AI introduces new regulatory requirements, especially in data privacy and decision transparency. From an EMAM perspective, the key insight is this: AI improves efficiency, but it also introduces new cost centers and risk vectors. Therefore, the correct approach is not AI reduces cost, but rather AI redistributes cost and risk across the system. The companies that win are not those that blindly automate, but those that redesign their economic engine with full visibility of these trade-offs. Having established the economic mechanics, we now translate this into strategic implications. This is where most analyses fail. They stop at efficiency gains and do not extend into competitive positioning. The first implication is that business model innovation becomes less relevant than incentive optimization. If AI is repackaging existing systems, then the competitive advantage lies in how effectively a company redesigns incentive flows. For example, in e-commerce, the traditional model relies on paid advertising to drive traffic. With AI agents, discovery shifts from platform-driven to agent-driven. Consumers increasingly rely on AI recommendations rather than browsing marketplaces. This changes the incentive structure from pay for visibility to optimize for algorithmic preference. The second implication is speed as a competitive moat. AI compresses execution cycles. Decisions that previously took weeks can now be made in real time. This creates a new form of advantage, not scale, but velocity. Companies that can iterate faster will dominate, even if their underlying model is not fundamentally different. The third implication is that data becomes leverage, not just an asset. In traditional frameworks, data is treated as a resource to be accumulated. In computational economies, data is valuable only if it improves decision-making and incentive alignment. This shifts the focus from data collection to data utilization. We can observe these dynamics across multiple industries. In consulting, AI is driving productization. Knowledge that was previously delivered through human interaction is now embedded in systems. The incentive model remains the same. Clients pay for expertise, but the delivery mechanism changes. In education, AI tutors replicate the traditional teacher-student relationship. The incentive remains learning outcomes, but the system becomes scalable and personalized. In finance, algorithmic trading has existed for years. AI enhances it, but does not change the underlying incentive, profit from market inefficiencies. The consistent pattern is clear. AI does not create new games. It changes how the game is played. From an EMAM lens, this reinforces a critical strategic principle. Do not chase novelty. Optimize structure. At the decision level, strategy must translate into actionable criteria. The question is no longer what is AI, but where should we deploy AI for maximum impact? We define a simple decision framework based on 3 conditions. First, repetition. AI performs best in environments with high-frequency repeatable tasks. This includes customer interactions, data processing, and content generation. If a process is not repeatable, AI will have limited impact. Second, clarity of incentives. AI requires well-defined objectives. If the system does not have a clear success metric, optimization becomes impossible. For example, optimizing for click-through rate without understanding conversion value can lead to misaligned outcomes. Third, measurability. AI relies on feedback loops. Without measurable outputs, the system cannot improve over time. These 3 conditions form the baseline for AI deployment. We then introduce a go/no-go logic. If incentives are unclear, do not apply AI. If data is insufficient, do not apply AI. If margins are low, prioritize AI deployment to improve efficiency. This prevents misallocation of resources, which is a common failure in AI adoption strategies. Next, resource allocation. A disciplined organization should allocate 70% of resources to optimizing existing systems, 20% to controlled experimentation, 10% to exploratory innovation. This aligns with EMAM principles of risk management and capital efficiency. The key is balance. Overinvesting in experimentation leads to fragmentation. Underinvesting leads to stagnation. Finally, we address organizational implications. Adoption requires cross-functional integration. It is not a standalone initiative. It affects operations, marketing, finance, and compliance simultaneously. Therefore, leadership must treat AI as a system-level transformation, not a tool-level upgrade. The ultimate decision is not about technology. It is about where to redesign incentives for maximum leverage. We conclude by reframing the narrative around AI. The dominant discourse positions AI as a force of disruption. This framing suggests that existing business models will be replaced by entirely new ones. However, our analysis demonstrates that this is a misinterpretation. AI is not a force of reinvention. It is a force of recombination and optimization. It does not change why people act. It changes how efficiently those actions are executed. This distinction creates a divide between two types of actors in the market. On one side, we have what we can call dreamers. These are individuals and organizations that chase novelty. They focus on creating entirely new models, often without a clear understanding of underlying incentives. On the other side, we have operators. These are individuals and organizations that understand systems. They focus on redesigning incentive structures and improving execution efficiency. Historically, operators outperform dreamers. This is because markets reward execution, not imagination. From a positioning standpoint, this creates an opportunity. If most of the market is focused on AI as innovation, then positioning yourself as an incentive architect becomes a differentiator. You are no longer competing on ideas. You are competing on execution capability. This is particularly relevant for entrepreneurs and consultants. The value is not in building AI tools, but in designing systems where AI enhances economic outcomes. We can summarize the entire thesis in one statement. AI does not change human behavior. It changes the cost and speed of aligning that behavior with economic incentives. This is the operator mindset. And this is the lens through which AI should be approached. Not as a revolution, but as a restructuring of the same underlying game.